Hi, I'm Dion from LegalCertMathsVideos.com. Now, this question 4 is generally easy, and parts A and B are actually especially easy. So we just start off with this one. We're told it's an arithmetic sequence. So we know the difference between 1 over A and 1 over B is the same as the difference between 1 over B and 1 over C. So we'll just show that here. 1 over B minus 1 over A is equal to 1 over C minus 1 over B. Now what we do here is we add 1 over B to both sides, and we also add 1 over A to both sides. So that is 2 over B is equal to 1 over C plus 1 over A. And what we want to do here, we want to get rid of the B on the bottom, so we just multiply both sides by B. So that implies 2 is equal to B times 1 over C plus 1 over A. Now this is kind of a bit awkward here, so we just change 1 over C to 1 over A. So that implies that 2 is equal to B into C plus A all over AC. Now what we want to do here, we want to get rid of this, we want to leave the B on its own. So what we do is we multiply both sides by AC over C plus A. So that implies 2 times AC all over C plus A is equal to B. That's our solution there. And on to the next part of the question here. We're asked to show that 1 over root of r plus 1 plus the root r is equal to this term here. What we normally do here, we might know from complex numbers, is we multiply by the conjugate cert of the denominator, which basically means multiply above and below by root r plus 1 minus root r. So that's just what we do here. So 1 all over square root of r plus 1 plus the root of r. Now we multiply above and below by its conjugate times square root of r plus 1 minus root r all over square root of r plus 1 minus root r. Remember, we're just multiplying by 1 really, so we're not really changing it. So then, root r times r plus 1, that is equal to root r plus 1 on top minus root r all over root r times itself, our square is just r plus 1. And then we multiply this by this, and this by this, they cancel out and give 0. And then we multiply root r by minus root r, that is minus root r. Or minus root r all to be squared, which is just r, so that means that they'll cancel out. And then we're left with just 1. So that's what we were showing the proof, equal to r plus 1 minus root r all over 1. So on to the next part of the question here. Well, generally we want to use this here for the next few parts of the question because it's just an easier expression to work with. Here we're showing find the sum to n terms of 1 all over root r plus 1 plus root r. Well, that is, we just rewrite that as the sum to n terms of 1 all over root r plus 1 minus root r. So we're going to say at r equal 1, that is root 2 minus root 1, which is 1. At r equal to 2, that is root 3 minus root 2. At r equal to 3, that is root 4 minus root 3. And at r equal to 4, you should be beginning to see a pattern here. That's root 5 minus root 4. So when we're showing this pattern here, now we're looking for the sum to n terms, so the sum of a certain amount of terms. Well, as you can see here, when we add up the first 4 terms, just say the first 4 terms for example, well these are going to cancel off here, these are going to cancel off here, these are going to cancel off here. So really the sum of the first terms, the sum of the first 4 terms is going to be your bottom left term here and subtract the 1. So the bottom left term here is the square root of r plus 1. So if we're asked to get the sum of the first 4 terms, we're going to have root 5 minus 1. So that implies the sum of the first n terms is going to equal the square root of n plus 1, which is same as our 5 here, minus 1. And on to the next part, we're asked to evaluate the sum of the first n99 terms. Well, as we know from earlier on, that is root n plus 1 minus 1. Root n plus 1 minus 1. So the first sum to n terms is equal to that. So the sum to the first 99 terms is equal So the root of 99 plus 1, which equals root 100, which is 10, minus 1 equals 9. So the sum of the first 99 terms in that geometric sequence equals 9. Okay, so if you found this video helpful or useful, please add me on Facebook or Twitter or subscribe to my channel on YouTube. Thank you.